Hello, welcome to our topical solution series for IGCSE at Maths 0606. In this video, we're going to look at the topic of logarithmic and exponential functions. The questions we have picked to solve in this video is from May-June 2019, paper 22. Let's go to the question. 7a. Solve LG bracket x squared minus 3 equals 0. With a command word solving, we know the ultimate destination we are supposed to arrive at as, yes, the value of x. Okay, now before we move on, we just want to make sure every one of us are comfortable with the shortcut symbol of log. Well, when they give the short form LG, we know that LG is actually representing log to the base of 10. Okay, once we are confident with that, we know what is the base that you can take advantage of to solve your questions. Now, given to us on the left-hand side, log the bracket of x squared minus 3. Let me make this clearer by putting back the bracket. Okay, now you have on the left-hand side, nothing much you can do, but on the right-hand side, something interesting you can work on. With the value of 0, back to our fundamental of the logarithmic rule, what can we draw from it? Equals, what does it from? Yes, we learn from log or whatever base. When they have the inside of 1, it will equal 0. That's what you get. Okay, let me just put it down here as a reminder of us. If we have log to any form of base, if the inside is a 1, then we know that this whole thing will surely give us a 0. That is the rule that we are going to take advantage on. With the left-hand side of 0, that we are going to make them into LG to the 1. Yes. Then from there, you have noticed that on the equation, on the left-hand side and the right-hand side, you have both of them with the LG. And therefore, you know that you no longer have to compare the LG. Therefore, what we have chosen to do is we just cancel them out and we bring only the remnant of them down to do our second step. The remnant of the left-hand side is x squared minus 3, and the remnant of the right-hand side gives us 1. And from there, I know, yeah, you have seen something very, very simple for you to process. Yes, you're just going to plus 3 both sides, and that gives you x squared equals to 4. And with the simple square root of the x squared, it gives you x and equals to plus minus of the square root of 4, and that naturally leads you to x equals positive and negative of 2. Then, as of now, let's do what we usually must do before we present the final answer. What is it? Yes, we must take the x value respectively and test it out in the original equation. Let's start with x equals to negative 2. When you put an x equals to -2, squaring it up, you got 4. 4 minus 3, you still get a +1. That works. Therefore, you conclude the acceptance of x equals -2. Now you're going to test out when x equals to +2. Yes, without much difficulty, you know that x +2 square 4 minus 3 +1, that also work. Therefore, you conclude acceptance of x equals to 2. That makes there are two solutions to 7a, which is x equals -2, x equals +2. That's the end of section A. Let's move on to section B1. At a glance, it may look somehow intimidating. Let's read the question. Show that for a bigger than 0, the whole statement as such may be written as x as sine 2x plus 5 plus a constant k, where k is an integer. K, without much being panicked, what we have to do is just keep our heart chill and cool, recalling all the basic, the fundamental logarithmic rules for our manipulation. That's how we're going to move on. What I did in this step is just simply copying them down. Then from what I noticed, yes, there is the power. There is the power of sine bracket 2x plus 5. Therefore, we will just invoke the power rule to bring that index down. That form for us the index of sine bracket 2x plus 5 ln a. And plus the next thing, what do? We note that the ln of the 1 over a. Now connect back to the indice rule. We know that 1 over a is equivalent to a to the power of -1. And that with that convenience, we go back to logarithmic rule, invoke the power rule, bring the -1 and multiply it to the front, and therefore it gives us a negative ln a. Then from the arrangement, we have noticed something interesting. We note that the first term in the numerator has ln a. The second term of the numerator also has a ln a. Therefore, it crosses our mind. We can factor out the ln a, leaving us to bracket sine 2x plus 5 minus 1. And from there, we are getting closer to the statement that they want us to make. Yes, why do I say that? You will easily see this. Yeah, I'm sure you have gone ahead of me. Good for you. Cancel out the numerator and denominator ln a. There you go. Once you cancel that out, you have left only for yourself sine bracket 2x plus 5 with -1. And that -1 is the integer k. Congratulations, you have turned the somehow looks complicated equation now successfully achieving a simplified of its form. Now we go to part 2. We notice that there is a integration questions. Therefore, as of this point, for those students who hasn't attended integration yet, do not panic. We will go and tackle these questions when you have done the integration and differentiation lessons. For those who have done differentiation integration, yes, you may proceed, and in order to make it easier for your progress, what I have prepared here is a quick revision for you. Well, for those students who hasn't taken this lesson yet, you are most welcome to follow through and to learn a little part of the differentiation and integration lesson. Okay, here if we were given a function of y equals cosine theta, and when we run the differentiation of y function with respect to theta, from what we have known that is going, in order to differentiate cosine theta, we know that from the formula differentiating of cosine, we will get negative sine theta. And with the friendly reminder, differentiating of cosine, we will always incur a change of sign in the process. Therefore, from cosine, we have turned it into sine, and from positive, we have conclude into a negative. That is when we do the differentiation of cosine into its results of negative sine theta. Okay, and we move on, the opposite, the inverse of differentiation, which is the integration. Therefore, as I stated here for your info, if we has got to reverse the differentiation, we will use integration. And of course, with respect to theta as well. Therefore, if you have obtained negative sine theta as a result of differentiating the y, now if you want to undo that differentiation, so what we do is I've just taken this result and put it here, and with the integration symbol, and we know that they just undo the process. Therefore, from sine, we will go back to cosine. And as the sign changing, yes, you remember that. Therefore, if the integration of negative of sine, we will harvest a positive cosine. Again, I need to emphasize, not a change of sign happens. All right, so this is a quick revision on this area. Using this knowledge, we're going to go back to tackle this question. Okay, now from the part 1, we know that this complicated log equation can be equal to sine bracket 2x plus 5 minus 1. Therefore, the smart you and me and all of us, we will substitute this complicated fella with its equivalent version. There you go. Therefore, we get the integration of sine. Okay, so sine, integrating sine 2x plus 5 minus 1 with respect to the theta. This is not supposed to be x, it's going to be theta. All right, let's put in there accordingly. We're going to, oh yeah, it is an x. Okay, theta is the one I used in the example. Yeah, I got mixed up. Okay, no problem. So now what we do, this is another part of the integration skill. Okay, I'm going to explain for those who hasn't yet learned this, you also can benefit from this. For those who has already learned, take this as a convenient, quick revision. Okay, now let me just, with the help of some highlights, let's going to do the revision. From sine, integrating sine, we get cosine. Okay, and then with the negative, with the note of changing of the sign from positive sign, now we get negative sign. Okay, now before we move on, we got to be careful with one more thing. The inside, okay, the inside of the sine function, that is 2x plus 5. So what the rule of integration does is we will divide the integration of the inside. Now you have no differentiation of the inside. So when you get the 2x plus 5 and you differentiate the inside, you know that you get the coefficient 2 left behind. And being the rules of integration, we divide the coefficient there. Okay, so for those who hasn't learned, do not worry. You will make everything clear when you have gone through that part of the lesson. Okay, so for those who have done, I'm sure you have got yourself a quick and awesome revision. Yes, now as of now, you have completely successfully integrate the first term. And now you move on to integrate negative. You're going to integrate 1. Yeah, the 1 you just copy down here. Now integrating 1, yes, you comfortably got for yourself. Integrating 1, you get for yourself x. Okay, then that we have also learned that this is indefinite integration with no limit given. Therefore, we plus a possible constant that was lost during differentiation. Therefore, we just put a plus c in case we have a constant in its original equation. And by slight rearrangement, putting the negative to the front to make it look better, that's how we get negative half cosine 2x plus 5 minus x plus c. There you go. You have successfully concluded this whole question and pocketed for yourself total 8 marks. Okay, so we have come to the end of this solution question and looking forward to see you in the next video. And before we say goodbye, once again, happy learning always. And see you soon. Bye-bye.